purpose of this quick video is to just provide an overview of how the GBA Interblockchain Communication will work. And this is the component that will allow the GBA token to move from blockchain to blockchain. For this specific video, I'm just going to focus on the Telos network, but really the concept should be pretty similar for any blockchain that we're going to integrate with. And it basically operates with events and oracles. So the centerpiece of it is this off-chain gateway here in the middle, and this will be running on a server. It says off-chain, and it's going to be listening to each of the blockchains that our token supports. And when it detects, listens to an event or hears an event that indicates that token wants to move to another blockchain, it will at the same time burn the tokens from the source network and issue those tokens onto the destination network. So it will guarantee that it's not issuing tokens without burning the other tokens. And what that does is prevent any type of double spend, which would be a big problem, right? If you had the same tokens or the same quantities on different blockchains. So in aggregate, the total number of tokens will not be impacted at all by having this gateway running. It's making sure to keep them all consistent. And so this diagram is showing two networks, our proof of authority network, the Telos network, but of course we can do this for any other blockchains. And I think we also have Steam that's either operational now or plans to be soon. All right, so I'll illustrate this using these two windows here. So I have a transfer agent that is going to it's actually going to run and issue the transfers just from the command line. All right. So this is going to send a random amount of the play token between 0 and 1 from Alice to Bob, and then from Bob to Alice, and then it just continuously switches back and forth. And again, I said it's sleeping for 2 seconds in between transfers. And in this window, I'm going to run the gateway, specifically the listener, and this is going to listen for the events. And for now, it's just printing them out. But this is where if one of the users was on a destination network, this is where the tokens would be burned and issued onto the other network. So I can just kind of stop this here, and you can see 0.11, 0.37, 113778. So it's very effective at picking up the accurate numbers. And one thing that we would make sure that we're doing on really the gateway on any of the chains that it's interfacing with is every time that it issues tokens, it'll perform, every time it performs that transaction, it'll write the block number of the source blockchain to disk. And that'll make sure that if something crashes or it loses power, then when the gateway comes back up, it'll pick back up from the block number that it last knew about, even if that block number is in the past 15 minutes or 15 years, it'll just go right back and start playing all the transactions from that time period, or from that block number. Okay, so what I'll do is I'll speed it up a little bit. I have a publish interval here, and I'm going to change it from 2 seconds to 250 milliseconds. And so our listener here is still operating. And so you can see it's just going, same thing, just going a lot faster. Pretty straightforward. I'll make one other change just to illustrate. So everything we've seen so far, the two examples have been single-threaded, and I wanted to just illustrate what concurrency would look like if we were going to use multiple threads. And so let's see. I'm just going to comment out a little bit of code here. I don't think we're going to need this in production, at least not anytime soon. But I'm sure one day we will. And this framework would certainly be able to scale with us. So here the gateway is still listening, and the transfer agent is going to go much faster. So here we're going to get into hundreds and hundreds of transactions. We're over 500 in just those few seconds, and our listener was able to keep up with us. Let me know if you have any questions. Thanks. I want to just show very quickly the Block Explorer. And this is a separate web application that would be available, and there's a handful of these Block Explorers that are compatible with EOSIO networks, and they essentially show all of the history of all the transactions that occurred on chain. So here you would see the account, for Bob, and just some basic information about his account. And here you would see a list of all the historical transactions. You can go into the detail of each transaction. Each one has a unique hash that's an ID. Of course, you have the timestamp, and here you see you actually see the transfer, and these are actually down here. These are messages that were sent on the blockchain from the blockchain to Bob and to Alice to notify their accounts that they receive funds. And this would be used if they had a smart contract deployed to their account and they wanted to run some logic every time they receive tokens, like they wanted to stake those tokens towards something, or take 10% to send to somebody else, or any logic like that, they would use that. But anyway, let's see. So then you have detailed information about that transaction. You have the JSON data. This is exactly what was within the transaction that was sent to the blockchain, from Alice to Bob. The memo is just the counter. That was the 598th transaction of that run, and the quantity, obviously. It also gets down, just to very minute detail of exactly the underlying data that changed. So here you can see that the balance record for Alice was, this is the old one. The red one is the old one. It went from, 11,969, and we replaced that record with this one, 11,968. And that equals the 0.74 play from up here. And the inverse of that is true for Bob. And this is just one of the great value propositions behind blockchain, is that end users, even of the application, can always search in history and figure out exactly what happened, when it happened, and this data is immutable forever. So just makes a very powerful type of database.